Hello everyone. Welcome to this channel. This is G Solutions, where we present solution for your needs. Today, let us try to understand inductors. What is its behavior when it is connected in series? We are still in circuit analysis, direct current. So for further understanding the inductors, I have given a value for L1, L2, and L3, namely 5 Henry, for L2, 10, and for L3, 15 Henry. So you'll notice here that the abbreviation for Henry is H, and the unit for the inductor are Henry, that is inductance. Since that we are to get point A and B, this is actually the equivalent inductor of these three inductors in series, a single inductor. So we're to find that it actually behaves like a resistor. So when you connect an inductor in series, you just have to add it, just take the summation of the inductances of the inductors. We have here 3, you can add another inductor here up to N. So you just add its inductances up to N also. Again, we are looking for this one, the single inductor, which has a point A and B, which we name as L sub AB. Okay, to be able to solve for this, again, it behaves like a resistor. So LAB is based on this given. You just add the inductance at L1 and the inductance at L2 and also at L3. So we have a value for that. L1 is 5 Henry plus L2, which is 10 Henry, and for L3 you have 15 Henry. So the total of that is 30 Henry. So LAB is 30 Henry. So if you are going to remove all of this one and replace it with a single inductor, the value of the inductor is 30 Henry. How about if we are to connect the inductors in parallel? Now again, since that it behaves like a resistor, if you are going to get the LAB for this, what is the LAB? In this case, we just take the inverse of the total inductor plus equals the addition of the inverses of the inductance of each inductor. So it will be like this, 1 over LAB, 1 over L sub 1 plus 1 over L sub 2 plus 1 over L sub 3, and so on and so forth. Even you add another inductor here up to N, so you just continually add it here, the value of the inverse inductance of that inductor. So therefore, we can get L sub AB. So we know that will be like this one, 1 over L sub 1 plus 1 over L sub 2 plus 1 over L sub 3. So therefore, we just substitute the values in our given. So you have 5 plus 1 over L2, which is 10, plus 1 over 15. And then if you have your calculator, you just press your calculator and it will give you 2.73 Henry. Okay, so that is the value of that. How about if it is connected in series and parallel? So we have here an example. L1 is in series with the parallel inductor L2 and L3. So just like the resistor, so if we are going to get the LAB of this kind of circuit, we just L1 plus inverse of this parallel connected resistor. So what will that be? That is 1 over L sub 2 plus 1 over L sub 3. Okay, so you just substitute our given. For L1, you have 5 Henry plus 1 over 1 over 10 plus 1 over 15. So solving for this, you just get your calculator and press your calculator, and presto, you have a value of 11 Henry. So this is simple presentation of circuit analysis in direct current in which our inductors are connected. Thank you.